So hello and welcome to a new tutorial. This time we are going to do something a bit differently. We are not going to focus overly much on styling our scene, but I would like to show you how you can do one of those animations that you've seen on screen. So we are particularly going to work on this animation. As you are going to see in the next couple of minutes, this is actually really easy to do in Blender. The bottleneck when you produce that kind of animations is most of the time rendering the final animation. This is also the reason why I chose to use a different render engine this time. So we are not going to do that in Cycles, but we are going to use Eevee. You can do that same animation in Cycles, so the technical part of that kind of tutorial is not going to change. It does not depend on the render engine. How your scene is going to look in the end is depending on the render engine. So even if you would like to stay in Cycles, you can follow along, but just style your biomolecules as you like in Cycles. If you want to join me using Eevee and giving it a try, of course, then of course you can also do that in Eevee. What you see here in that scene is just a very simple setup. So we have in that case an enzyme, it's an imine reductase. We have a substrate that binds into our active site, and there is also a cofactor present that as you can see on the left side. And the animation that I would like to produce with you is just the substrate finding its way into the active site. You can also see there are a couple of like dust particles flying around, so we are also going to incorporate that kind of animation into the tutorial. But apart from that, I would say let's just start. Okay, so I'm already here in Blender. I already loaded everything into the scene. If you're unsure on how to load biomolecules into Blender, I have a couple of tutorials talking about that as well. So just go to either the playlist, in that case it would be the Blender for Biochemists playlist, or just scroll through the couple of videos that are available for you. When you loaded your biomolecule into Blender, and if you would like to join me in using Eevee, you can just simply go to the Render tab and choose Eevee instead of Cycles. And that is basically it. As soon as you jump into the rendered mode in your viewport, you exactly see what Eevee is famous for. So Eevee is really great when it comes to real-time rendering. And we get a very sharp and crisp image immediately without having to wait as we normally have to do with Cycles. So this is one of the huge advantages in Eevee. If you just start using Eevee, by the way, I also just start using Eevee, so I have a lot of things to learn still in Eevee. You might recognize that shaders and materials are done a bit differently in Eevee, and I'm not going to go into that in that tutorial. As I said, I still have to learn a lot, and I don't feel comfortable giving you tips on that, but there are plenty of other great tutorials about shaders and materials in Eevee. So I would say that you resort to tutorials from content creators that are experts on that. So this tutorial, as I mentioned, is purely going to be about the animation and the workflow and how to produce the animation. So what you see on my screen here is what I mentioned already. I have a biomolecule. It's an enzyme that consists out of two subunits, in my case the yellow one and the red one. Then on the inside of the active site, I have my substrate positioned here. This is this molecule, and then there is a cofactor on that side. What I would like to produce now is, of course, my substrate flying into the active site, as I mentioned already. And the best way on how to do that is just to start with the way your molecule is loaded into Blender without any kind of modifications. So, of course, you need to have separate objects. I'm just going to lock those spheres quickly, because otherwise I always select them. So the only thing that is important is that your objects are separated from each other. So your substrate needs to be a separate object. If you want to do an animation with your cofactor as well, you can have that separated as well. If you would like to even animate both of your subunits, also make sure that those are separated. I just separated all of those objects just in case I need them, but I'm just going to do an animation on my substrate. The way animations are done in Blender is actually super simple. You set coordinate keyframes where your object is going to be in a specific timeline. The timeline that I'm referring to is visible at the bottom of your Blender window. And if you, for example, hit the spacebar, your animation starts to play. So of course our molecule is not moving yet, but what you see is that our dust particles are already moving. How to install those? This is also something I'm going to tell you later on in the video. But just to show you that now actually we are in an animation space. So our molecule should have now an animation going from the outside to the inside. The easiest way on how to do that is to start actually from the back. So what I'm going to do for a 100 frame animation is I'm going to set my cursor at the very end of my animation, and I'm going to add the first keyframes. And this is also super easily done in Blender. So what you need to tell Blender is that this location in space and time should be remembered. So this is our end position of our molecule. So that means we need to lock the rotation, the location and the rotation here. And you insert keyframes by just hovering your mouse your mouse cursor over the area you would like to lock, and then you hit just I on your keyboard. Then you see that the table here turns yellow. That means you inserted the keyframe, and I'm going to do that for both location and rotation. And in the timeline setting here, you also see that a keyframe is inserted, which is that orange or yellow diamond that you see here. Okay, so now our molecule has its end position. So this is where the animation is going to end. And the next important step is just to move the cursor on the timeline away from the keyframe that we just created. And then we are going to move to the next position of the molecule, and this is going to be the position where it is trying to squeeze its way out of the active site, or if we play the animation in the right correction, where it's going to squeeze its way in. So for that I'm going to zoom in, and I'm just going to grab my molecule and find exactly that position. In my case that involves a bit of rotation as well, because I would like to have it fit exactly between those narrow areas, like that. When I found that position and I'm happy with how it looks, I'm just going to insert a keyframe again by just hovering above location, press I, rotation, press I. And then this part is also fixed. So now we can also check how our first animation looks like by just moving our cursor here. And we can also check if there are some not so optimal transitions. As you can see in my case, the substrate is actually touching parts of the protein, and I would like to fix that. So for that, I need to make sure that it does the rotation actually before it enters the channel of the active site. So I need to push it back a bit. I can correct it quite easily. So we can override keyframes. In my case, I just need to grab my molecule and move it back a bit, and also move it to the left a bit. And then I'm just going to hit I again while having the cursor on my old keyframe, and this is going to fix that mistake. So now we see the molecule does just the rotation, and before it moves out of the active site, it stops. And the final animation that we need to find is when we go to our first keyframe, to our first frame of the animation. We are just going to grab the molecule and have it fly out of the active site in front of the camera. So to move it closer to the camera, here it is just necessary to find a new alignment. I'm going to go for something like that, so that the molecule faces the camera and nicely shows the structure. And that is really it. So you can also incorporate a bit of rotation here as well. Something like this. and then the keyframe is going to be set by hitting I again. And if I play the animation now, we see that our molecule flies into the active site and nicely finds its way in the final position. And this is really all that's to it. If you would like to have certain areas of your animation a bit faster, you can move keyframes closer to each other. So for example, if I would like to have the final orientation part slower, but the molecule moving towards the active site a bit faster, I'm just going to grab our middle keyframe and move it towards the start of our animation. And if I replay that now, you see that this part is way faster, and then the orientation phase afterwards is way slower. By keeping it in the middle, you ensure that both parts are approximately have the same length. In this case, they have exactly the same length. If you start from a default scene in Blender, you might recognize that your animation always has 250 frames. That's just a default setting. You can easily shorten that by changing the number to, in that case, 100, because I would like to have a shorter sequence. If you would like to have your animation go slower in general, there is also a feature in Blender that helps you do that very quickly, and you can find it in the output properties menu under time stretching. So there is new and old. So if it's 100 and 100, then you have a 1-to-1 speed basically. If we would like to speed it to just half of the velocity basically, you just type here 200, and then the complete animation is going to be played way slower. Of course, you also need to render more frames. So in this case, we would have a 200 frame animation to play the full sequence, because it's twice as long, of course. So this is a quick and easy way on how to get a slower animation that involves every part of your animation. So also my dust particles, for example. If you just would like to have your molecule move faster, then of course it is easier to do the shift with the keyframes rather than prolonging the complete animation. Okay, so now we set, now we actually taught our molecule how to fly. And there are a couple of settings that I would like to quickly do just for a bit of styling. So as you learned already in the last tutorial, I am a big fan of depth of field. So I'm going to activate that as well. And I already have some settings here that are quite convenient to have and make that kind of effect quite easy. So I linked the focus area to my molecule. That can be easily done by just using the biped or select your molecule. In my case, I called it Substrate from the menu. That also means that if your molecule moves, the focus area is going to follow the molecule. And that creates that kind of seamless transition that you see and that kind of focal effect that you normally know from cameras if you focus something that is in the distance. And this is, I think, a quite neat effect to have here. So I'm going to definitely apply that. So this is something that I added, and also I promised to tell you a bit more about how to create the dust particles that you see here. So you see that the complete molecule is surrounded by tiny particles, and those are done with an emitter. Again, if you followed the last styling tutorial, this is not a new technique for you. In that case, I was using 2 icospheres. They are hidden now, but I'm going to unhide them for you so that you see how the scene is constructed. So the emitter is basically an egg-shaped object that covers my complete biomolecule. And the thing that is emitted is again just a very simple icosphere, or a sphere in general, that is hidden behind my background so that it doesn't disturb the scene. And the setup here, there is one tiny change in comparison to what we had for the last tutorial. In that case, it's important that you choose where those particles are emitted from. And in that case, it should be an emission from the volume and not from the vertices. Then for the physics, I decided to have them be emitted as voids. Voids are just objects that stay close to the emitter, so they don't fly away, but rather just linger there. And this is perfect because we would like our particles to stay there. And then again, I just hit the emitter so that the only particles are left. And this is all that's to it here as well. And that kind of blurry effect is due to the camera settings. So this is also something that comes naturally. So if I played it again, that would be the complete animation. Of course, you can animate everything in your scene like that. So for example, if we would like to first assemble our protein, for example, before the substrate goes into the active site, that is also something that we can easily do. I'm going to actually try and see how that looks like. So for example, if we, for that I just need to turn off the, well, let's go in the solid view, that's easier. So I'm just going to select one of the subunits. But of course, we need to define the end position first again. So one of the subunits, select them, insert the keyframe where they should end up, exactly as we did it before. Then jump to the first keyframe and then move your subunits where you would like them to have. So I'm going to move them a bit up. And oops, I forgot to insert the keyframe. Of course, insert the keyframe, otherwise the change is not going to take. And also do a bit of rotation here as well. And insert a new keyframe. And if I play the animation again, now you see that the subunits are not aligned yet. So they basically form while the substrate is flowing towards them. There was an issue now with the timing, so I'm just going to check that quickly. Yeah, so the problem now was that the animation ended at frame 200, but of course we would like it to end at 100, so at the same position where our molecule finds its position, or probably even earlier. So what I'm going to do is just select one of my subunits, select the last keyframe and move it to 80. So it's 20 frames before our molecule arrives in the active site. Do the same thing for my other subunit, and let's see how it looks if I play that again. So now the subunits actually meet before the molecule enters the active site. And now I can stretch the time again, put it to 200 to have a slower animation. And then if I play it again, now it would be way slower and smoother. Let's see how that looks in the rendered view. So if I go to the start again, let's watch it again. Yeah, so that would be then an even more complex animation. So I think now you get the concept on how to do animations or how to animate objects in Blender. It is done via keyframes, and it is actually, if you get a hang of it, super easy to do. The last step that I would like to incorporate is to show you how you render the final animation actually. In that case, you go to the Output Properties tab, and there is, in the output window, you can choose where your animation should be saved. And I'm going to also save that in a new folder, create the path where it should be saved. Then I'm going to go into the solid mode and just hit render animation instead of render image. And what happens now is that every frame that you created is going to be rendered into that folder. And what you can see already here is that Eevee renders way faster than Cycles does, as I mentioned before. So in that case, one of the frames, in my case, takes between 3 to 5 seconds, which is significantly faster than the same setting for cycles. So now, of course, you have to wait until all of your frames are rendered, and then you can combine those frames into a smooth animation that you can play in the end. So I'm going to wait until every frame is rendered, and then I'm going to come back to you again. Yeah, and this is now the final outcome. So that would be the simpler version of the animation, where we just have the substrate going into the active site, and also the more complex version of the animation, where first our two subunits fold into the dimer, and while they do so, also the substrate goes into the active site. Yeah, and the last part that is left is just how we get a video out of our frames. So if you would like to use the single frames to be compiled in an external software, you can use them as they are. You can also compile them inside of Blender. For that, you go into the video sequencer workspace, and here you go to add image sequence. Then you navigate to all of your frames that you generated previously and make sure to select all of them and say add image stripe. And in the output window, you select the format that you would like to have. So you can see that you can choose between different formats, and also here you have different settings for encoding, MPEG-4 for example, and so on and so forth. So set whatever you like to have here, and your video is going to be saved in the same path that you created before. And to do the final render, you can go to render and render animation again, and then your images are going to be compiled into one video. It looks a bit rocky here, but it's going to be a smooth video in the end, and then you can insert it into any kind of project you want, like in a presentation on a website, and so on and so forth. Good. So with this, I would say I hope that you got some inspiration for animating your biomolecules. And I would like to end with saying thanks for watching and have fun with Blender. See you in the next tutorial. Bye.